Alright, hello again everyone, Mr. Cruze here with another lesson for you, this time geometry. We're going to be learning about the surface area of pyramids and cones, okay? Now, we have a little bit of a problem here. Pyramids and cones have an interesting little thing that prisms and cylinders do not have, okay? They actually are going to have two heights. They're going to have a regular height, which is obviously just straight down from the top of the pyramid, or the cone, straight down to the middle of the base, okay? That's actually how tall the pyramid is, from top to bottom, okay? But they also have this crazy thing called a slant height, which is really the height of the triangle face on the side, okay? Obviously, you can imagine what's going to happen here. We're going to end up having something that involves the Pythagorean Theorem. Your actual height's here, your slant height is there. The height is always going to be this tall part. The slant height will always be the hypotenuse, every time, okay? And then this bottom part is actually, you'll notice, half of your side length. So this is half of the side length, okay? So we'll have to be careful there, alright? I'm going to do a quick example here where I have Pythagorean Theorem. So it says find the slant height of the pyramid to the nearest whole number. So as you can see, I could draw there, and I know that's the same as this. This is all the same. So that means this is 100. It's half of half of 200. Okay. So you actually have a triangle here. The height is 100. I just told you this is 100 because it's half of the length of that edge, and this is the slant height. Slant height is always the hypotenuse. So real briefly, you have to do 100 squared plus 100 squared equals your slant height squared. 100 squared is 1 with 4 zeros after it, 10,000. So we have 20,000 equals your slant height squared. So you just have to take the square root of it. Please don't divide by 2. Make sure you take the square root. Okay. And you get 141.4-ish. It says round to the nearest whole number. So our slant height is 141 feet. Okay. So again, you might have to use Pythagorean Theorem here. Just be careful with it. A squared plus B squared equals C squared. Alright. So, anyway, we're going to have a little shortcut formula again for the surface area of a pyramid. Obviously, the pyramid has a base. It only has one base this time. And we're going to use that perimeter again. So P. But you'll notice this time, all of the lateral faces, the sides that are not the base, they all have the same height, and it turns out to be the slant height. Okay, so it's actually base plus PL. But there's one other thing we have to take into account. Those faces are triangles now, not rectangles. Obviously, area of a triangle is 1/2 the area of the base times the height of that triangle. So your full formula is base plus 1/2 perimeter times the slant height. Okay? So, we'll need to know all of that. So actually, you don't even need the regular height for surface area. So let's try some. Find the surface area of the following pyramids. First thing I would do is find the area of the base. In this case, the base is a square. 7 times 7 is 49. Okay. Perimeter of the base, well, it's 7 all the way around. 7 plus 7 plus 7 plus 7 is, of course, 28. 7 times 4, right? And the slant height they actually gave to us, that's the blue line there, it's 9 inches. Okay, so I just go base plus 1/2 perimeter times slant height. And then we just have to figure that out. Let's see. Half of 28 is 14. 14 times 9 is 126. So 126 plus 49 is 175. And this is still surface area, so it's square inches. Okay. Alright, so let's see. Start again. Area of the base. So the base at the bottom is again a square. 10 times 10 is 100. Right? Length times width. The perimeter of the base, it's 10 all the way around, so 10 times 4 will be 40. But you'll notice this time, we don't have the slant height. We have the actual height, the one that goes to the middle of the base, okay, we need to find this slant height. So usually what I do is I draw a triangle. I know this is 12 tall. I need the slant height. This is in the middle of the pyramid, so it's half of 10, so it's 5. Okay. I have to do a quick Pythagorean theorem here. 12 squared plus 5 squared equals L squared. 144 plus 25. Hopefully you know this, 169. So the slant height is the square root of that, which is 13. Okay. Now I'm ready to do my formula. Area of the base plus half perimeter times slant height. So we have 100 plus, let's see, half of 40 is 20. 20 times 13 would be 260. So we have a total of 360 square feet. Okay. Example 4 here. Again, area of the base. You'll notice this time, the base is a triangle. They actually gave you the area of the base. They went ahead and told you it's 35.1. Okay? It's nice of them. They'll do that sometimes, so just be on the lookout for that. Okay? The perimeter of the base, you'll have to find it, but you'll notice all these sides are marked as the same. They're all 9, so it's an equilateral triangle. 9 times 3 will be 27, because there's three edges on the bottom. Our slant height, you'll notice they gave it to us. It goes to the edge, not to the center. So that's 12 centimeters. So then we just go with our formula. 35.1 plus 1/2 perimeter times the slant height. And you just have to type that in your calculator. And you get 197.1 square centimeters. Okay? Again, the hardest part of some of these is just finding that slant height. If they give you the height, you might have to find the slant height. Okay? Just Pythagorean theorem it up. Alright, again, remember how yesterday prisms and cylinders behaved exactly the same way? Well, guess what? Cones are no different than pyramids. They will still have a regular height. They will have a slant height as well. Okay, so we're going to have to be careful. But think about the formula for a pyramid for a second. We have base plus 1/2 PL. Well, again, the area of the base is a circle for a cone. So the area of the base is pi r squared now. And the perimeter is the same as circumference when you're talking about circles. So that's 2 pi r. And a cool little thing happens here. The 1/2 and the 2 cancel each other out. So your new formula for a cone is pi r squared plus pi rl. Pi r squared plus pi rl. Alright, so let's try some. You just have to have the radius and the slant height. Again, you don't even need the height. So let's see. Pi times the radius squared plus pi times the radius times the slant height. You'll notice they gave it to us. Okay, it's the length along the edge there. So 4 squared is 16 pi. 4 times 6 is 24 pi. 16 pi plus 24 pi is 40 pi. And then when you take 40 times 3.14 and you round it, you get 126 square inches again, because we're still finding surface area. Alright, let's do number 6 here. You'll notice again they gave us the radius and they gave us the slant height, so we're good to go. Pi times the radius squared plus pi times the radius times the slant height. So we have 100 pi here, because that's what 10 squared is. 10 times 12 is 120. So we have a total of 220 pi, which again, when you multiply by 3.14 and you round it, you get 691 square inches. Okay. Number 7 here. This is the trickiest one, because you'll notice this time they didn't give you the slant height. Okay? So you're going to have to do Pythagorean Theorem again. You notice this time the radius is at the bottom and the height is over here. We need the slant height. You might recognize this, hopefully. We've seen it enough. So 9 plus 16 equals L squared, so that's 25. So that means the square root of that, the slant height's 5. Okay? Again, just make sure you're good with Pythagorean Theorem. A squared plus B squared equals C squared. If you can do that, you're ready to rock. So here we go. Pi times r squared plus pi times r times L. So we have 9 pi plus 15 pi and we get a lovely 24 pi, which again, when you multiply by 3.14 and you round it, you get 75.36, which rounds to 75. Alright. So that's it. That's your surface area of a pyramid and a cone. Again, pyramid, you just have to be careful. It's base plus 1/2 perimeter of the base times the slant height. And for a cone, it's basically the same thing, pi r squared plus pi rl. They're the very same formula. It's just the cone has a circular base, and a pyramid could really have any base it wants. Okay? So those are the formulas you'll need. Just be careful. Remember, sometimes you might have to use Pythagorean Theorem to find the slant height, and everything should be good. If you have any questions, please feel free to tweet me at Mr. Cruze Math. You can email me. But make sure you're working on your homework, and please be good for my sub, alright? I will see you guys here in a couple days. Take care.